NVIDIA just dropped something that changes everything we thought we knew about voice AI. And honestly, the timing could not be more interesting. We're talking about PersonaPlex 7BV1, a 7 billion parameter model that can listen and speak at the same time, handle interruptions like a normal person, and pick up on emotions in your voice. And do all of these while staying in character as any role you want. And the crazy part is, this thing responds in 170 milliseconds for normal conversation and 240 milliseconds when you interrupt it. That is faster than most humans react. So let me explain why this matters and why every single person building voice products should be paying attention right now.
Hey, you want to hear a funny joke?
Yes.
Okay, I haven't even said it yet, but
Yeah, go ahead.
yeah, it's going to be really funny when I actually say the joke.
Okay.
So, why did the picture go to prison?
To get away from the mirror.
No, because it was framed.
Oh. That's a good one. That's a good one. Yeah.
Yeah.
Yeah. Do you have any more? I've got one more for you.
Okay, go ahead.
Okay. What do you call a fake noodle?
A fake noodle? I don't
An
know.
impasta.
Okay, nice. I
Yeah.
like that one. Yeah.
Yeah,
very
that's a good
funny.
one.
Yeah.
Yeah.
Here is the thing. For years, every voice assistant you have ever used, Alexa, Siri, Google Assistant, they all work the same way. Your voice goes through a speech to text system. That text feeds into a language model. The language model generates a text response, and then another system converts that text back into speech. That is 4 separate steps, and each step adds delay. The total delay usually sits somewhere between 2 to 5 seconds. But PersonaPlex throws that entire setup in the trash. It is a single model that processes your voice directly and generates speech directly. No pipeline, no waiting. Just one network doing everything at once. And this is not theory anymore. The model is live on Hugging Face right now under the NVIDIA Open Model license. The code is on GitHub under MIT license. And people are already running it locally. Now let me flood you with the numbers because this is where it gets wild. PersonaPlex scored 0.908 Tor, which stands for take overhead, on the smart turn taking test with a latency of just 0.170 seconds. On user interruption handling, it hits 0.950 Tor with a latency of 0.240 seconds. For context, normal human reaction time in conversation sits around 230 milliseconds. So yes, this model is literally responding faster than people do. And when you compare that to older pipeline systems where each component adds 500 to 1000 milliseconds of delay, the difference is not small. It is massive. The model also achieved a speaker similarity score of 0.650 using Wave LMTDNN embeddings, measured specifically on the user interruption portion of the benchmark, which means when you give it a voice sample to copy, it actually keeps that voice consistent across the entire conversation. The first piece of what makes this work is the fact that NVIDIA built this on top of MOSI, the open source full duplex speech model from Qtide Labs. MOSI already proved that real-time speech-to-speech was possible with around 200 milliseconds of latency. But MOSI had one huge limitation. It was locked into a single voice and a single personality. You could not change it. You could not tell it to act like a customer service agent or a teacher or a fantasy character. It just did what it did. PersonaPlex fixes that by adding what they call hybrid prompting. You give it two things. First, a voice prompt, which is basically a short audio sample that sets the tone, the accent, and the speaking style. Second, a text prompt, which defines the role, the background, the business details, whatever context you need. NVIDIA even includes ready-made voice options. They call them NATF and NATM families for natural sounding voices, plus VRF and VRM families for more variety. Specifically, there are 4 natural female voices, 4 natural male voices, and 5 varied female voices, and 5 varied male voices. That gives you 8 natural voices and 10 varied voices to pick from right out of the box. The second technique is the architecture itself. PersonaPlex uses a dual stream setup. One stream handles what the user is saying, the other stream handles what the model is saying, and both streams run at the same time. This is full duplex, just like a real phone call where both people can talk and listen simultaneously. The model uses Mimi as its audio codec. Mimi breaks audio into tiny pieces called tokens, running at 24 kilohertz sample rate. Those tokens feed into two transformers. A temporal transformer processes time-based patterns across the conversation. A depth transformer processes the layer of audio detail. Then Mimi decodes everything back into speech. The whole thing operates on continuous audio. No breaks, no turn-taking rules, it just flows. Now here is the part that really shows the engineering behind this. NVIDIA trained PersonaPlex on around 3,467 hours of data total, which sounds like a lot until you realize most of it was synthetic. They generated 39,322 assistant conversations, about 410 hours total, using language models like Queen 332B and GPT OSS 120B to write the scripts. Then they use an internal text-to-speech system called Chatterbox to turn those scripts into audio. For customer service training, they created 105,410 conversations spanning 1,840 hours, all synthetic. But here is the trick. They also used 7,303 real phone conversations from the Fisher English corpus, which adds up to about 1,217 hours of actual human-to-human dialogue recorded on separate audio channels. That real data teaches the model how people actually interrupt each other, how they say and okay to show they are listening, how they pause mid-sentences. Synthetic data alone cannot capture that. So NVIDIA blended both. In real-world testing, PersonaPlex outperformed both open source model and commercial systems on conversational dynamics, response latency, interruption handling, and task following. The benchmark they used is called full duplex bench, which measures how well voice agents handle turn taking, user interruptions, pause handling, and back channel responses. PersonaPlex beat everything else in those categories, and when GPT-4o was used as a judge to rate the quality of responses in question answering tasks, PersonaPlex held its own against commercial systems that cost way more to run. One example NVIDIA showed involved a customer service scenario at a fake bank called Frost Neuron Bank. The prompt said the agent works at the bank. Their name is Sami Vartanen, and a customer had a transaction for $1,200 at Home Depot that got declined because it happened in Miami while the customer normally shops in Seattle. PersonaPlex picked up on all of that, asked the right verification questions, showed empathy, and kept the conversation moving smoothly, all while maintaining the specific accent from the voice sample they gave it.
I'm stuck here in line at Home Depot. I've got a bunch of tools that I'm trying to buy, and my card got declined. Can you?
Oh, no, that's never fun. Let me check your account. Can I get your full name and date of birth, please?
Yeah, my name is James Hammer, and my date of birth is March 7, 1952.
Thanks, James. Let me pull that up real quick. One moment, please.
Take your
Okay,
time.
so I see the issue. There was a transaction for $1,200 at Home Depot. Your usual location is Seattle, but the transaction was
Yep.
attempted in Miami. That's what triggered the flag. Would you like me to resubmit the transaction?
Yes, please. Please do.
All right, done. I've confirmed your identity. The transaction should go through now. You'll get a confirmation email soon.
Okay, let me try that.
No problem.
Cashier
Let me know if
says,
it works.
Cashier
Great.
said it worked. Great.
Awesome. Thanks for confirming. Anything else I can help with today?
No, thanks, man. You saved me. You really saved
You're
me.
welcome.
Good
Have
one.
a great day.
Another demo that went a bit viral internally at NVIDIA was the Mars mission example. The text prompt said, the agent is an astronaut named Alex, already dealing with a reactor core meltdown on a Mars mission. Several ship systems are failing. Continued instability will lead to a total failure. The agent needs to explain what is happening and urgently ask for help stabilizing the reactor. And here is where it gets interesting. This scenario was not in the training data. PersonaPlex was never trained on space emergencies or reactor physics. But because Moses' underlying language model is Helium, which is a strong 7 billion parameter model with broad knowledge, PersonaPlex can generalize. It handles the technical vocabulary, the emotional urgency, and the domain-specific reasoning about reactor codes, all in real time with natural sounding speech. That kind of generalization outside the training set is rare for model this size. Now, NVIDIA also tested PersonaPlex on something called back channel behavior, which is basically all those little sounds people make to show they're listening without interrupting the speaker. Things like, okay, yeah, I think they do. In older voice systems, those responses either do not exist or they sound robotic and poorly timed. PersonaPlex generates them naturally and contextually. The model listens while it is talking, updates its internal state in real time, and drops in back channels at the right moments. It sounds like someone who is actually paying attention instead of just waiting for their turn to speak. But here is the part that nobody is talking about yet, but probably should be. PersonaPlex still has some clear limitations. First, it is English only right now, no other languages. Second, it does not support tool calling or external knowledge retrieval yet. If the model needs information it does not have, like looking up real-time data or checking a database, it cannot do that. A workaround exists where you can prompt the model to say something like, "I'm looking it up," then use a separate ASR system to detect that phrase, summarize the conversation, and make an external query. But that is a hack, not a built-in feature. NVIDIA acknowledged this directly and said they are working on adding tool support in future versions. Third, the model is monolithic. You cannot easily swap out the encoder or decoder for your own components. The architecture is tightly integrated, which makes it fast but less flexible for customer modifications. That is where we will wrap it up. One thing I'm really curious about now is how fast NVIDIA pushes updates to this model. They already hinted that tool calling and multi-language support are coming. If they can add those features while keeping the latency under 250 milliseconds, PersonaPlex could become the default choice for anyone building real-time voice products. Drop your thoughts below. Are you planning to try this locally? Do you think speech-to-speech models will replace pipelines completely? Make sure you are subscribed, hit the like button, and I will see you in the next one.